All right, today we're going to talk about something that is fundamentally changing defense technology as we know it. We're talking about putting artificial intelligence right where the action is, what's called the tactical edge. And look, this isn't just about getting faster machines. This is about completely redefining the very nature of conflict itself. So, to really get a handle on just how big a deal this is, you've got to ask yourself one really critical question. What happens when war starts moving faster than a human can think? I mean, really think about that, because that is the core problem that AI at the edge is being built to solve. You know, when you boil it all down, the issue is speed, plain and simple. Modern conflict? Well, it's just moving at a pace that has completely outstripped our ability to make decisions fast enough. And that's created a massive vulnerability, and it's all about the ticking of the clock. Okay, let's make this real. Think about a classic drone strike from, say, a few years ago. You've got a drone up in the air, it captures some really critical video. But then what? That raw feed has to get beamed, thousands of miles back to some command center. Then a team of human analysts has to sit there and sift through hours and hours of footage before a target can finally get approved. We're talking 24 to 36 hours for the whole process. By then, forget about it. The target is long gone, the intel is totally stale, and you've lost this perfect window to really understand what the adversary was up to. So you see, this old way of doing things, this centralized model, is not just way too slow, it's also incredibly fragile. I mean, the whole thing relies on having this perfect, constant, high bandwidth connection back to headquarters. So what happens if you're up against an enemy who can jam or cut those communications? Well, that dependency becomes your Achilles heel. It's a fatal weakness. So how do you fix a problem that big? Well, the answer isn't just a small upgrade. It's a complete paradigm shift. We're not talking about just making the old system a little bit faster. We're talking about building something entirely new. And it all revolves around this idea called the tactical edge. So what is the tactical edge? It's actually pretty simple. It's just where the action is happening. That's it. It means you take all that computing power that used to be in some far-off data center, and you move it directly onto the device itself. Right onto the drone in the air, right onto the satellite in orbit, or even on to a device a soldier is carrying. And when you do that, the difference is just night and day. Look at this. Instead of processing data in some far-off center, it's all happening right there, on the device. So that decision cycle, it goes from hours down to seconds. And here's the kicker. The system becomes resilient. If you lose that connection to home base, it doesn't matter. It can keep on working. And of course, your hardware priorities completely change. It's not about building the biggest, most powerful machine anymore. It's all about something called SWaP-C: size, weight, power, and cost. You need it small, light, and efficient. There's this great analogy from Brendan Beam at GDIT that just nails it. He says it's like owning a Porsche. At the edge, that AI system can work completely on its own, in any condition. That's its core strength. But when it does get a connection back to the cloud, well, that's like being on the Autobahn. You can really open it up, tap into all that massive computing power, update your models, get even smarter. It really is the best of both worlds. Okay, so that's the theory. But what does this actually look like in the real world? Let's dive into 3 concrete examples of how this AI is being used in the fight right now. First up, drones. And this is a big one. With AI on board, a drone stops being just a flying camera and becomes an intelligent agent. You have systems, like from Project Maven, that can analyze video feeds as they happen, in real time, and spot and classify potential targets with over 90% confidence. And get this, in some cases, they're actually more accurate than a human analyst. This tech has already been used in places like Iraq and Syria, and it has just completely collapsed that kill chain we talked about. All right, second example, space. Satellites are constantly sucking up just unbelievable amounts of data. Trying to send all of that raw data back down to Earth would create a traffic jam like you wouldn't believe. So instead, AI on board the satellite acts like a filter. It sifts through everything right there in orbit, figures out what's actually important, and then beams down only the validated, need-to-know intel straight to a commander's tablet on the ground. Think about that. The satellite is talking directly to the soldier. And third, let's bring it right down to the individual soldier. Picture Matic, okay? The environment is pure chaos, and they're trying to treat multiple casualties at once. It's an impossible task. But what if they had a tool, a wearable AI called the Digital Triage Assistant?
It pulls vital signs from sensors on the wounded, instantly figures out how severe each injury is, and gives the medic clear, objective guidance on who needs help first. It takes some of that immense cognitive load off their shoulders, and it absolutely saves lives.
So this tech is obviously incredibly powerful. But here's the thing. Building it is really only half the battle. Turns out, the biggest hurdles aren't about the code or the silicon. They're human. They're institutional. Yeah, there was this panelist at a recent defense summit who just put it so bluntly. He said, "Our problem is adoption." And that really says it all, doesn't it? The tech is often there. The real fight is getting it into the hands of the warfighters who actually need it. And this really gets to the core of the tension, the central paradox. America has the best innovators on the planet, no question. So the problem isn't dreaming up the tech. It's the painfully slow, bureaucratic machine that has to approve it and roll it out. I mean, how do you pick a winner, scale it up, and then train more than 2 million people to use it, all while moving at the speed of modern war? It's a huge challenge.
And a huge piece of solving that adoption puzzle boils down to one simple word: trust. This is where this whole field called explainable AI, or XAI, is so critical. The idea behind XAI is to build AI models that don't just spit out an answer, but can actually explain their homework. They can tell you why they came to a certain conclusion. And for a commander who has to make a life-or-death call based on that AI's recommendation, that why is absolutely everything.
Which, of course, brings up a really thorny question. The whole point of all this is speed, right? But if a commander doesn't trust the AI's recommendation, and they feel like they have to manually redo all the work to verify it, have you actually gained anything? Nope. The human bottleneck is right back in the system, and that whole speed advantage just evaporates. Trust isn't a nice-to-have here. It's an operational necessity. So what's the end game? What's the big picture here? Well, it's about building a defense architecture that is completely integrated, totally resilient, and just intelligent from the ground up.
The grand vision for this is something called JADAD-2. That's Joint All-Domain Command and Control. Basically, it's a unified network where every sensor can talk to every shooter. And powering it all are these incredible techniques like federated learning. This allows all the different AI systems out there, on drones, on ships, on satellites, to learn from each other's experiences, to get smarter together and adapt to new threats, all without ever having to share the sensitive raw data they're collecting. It's collaborative intelligence on a massive scale.
Look, there's no doubt this technology is a monumental leap forward. It's crushing decision cycles and building a much more resilient force. But as we keep pushing this incredible AI further and further to the edge, giving it more speed, more autonomy, we're left with a pretty profound question to chew on. As the machine gets faster, how do we make sure the human remains meaningfully at the center of it all?